And good afternoon, everybody. And thank you for joining us today on this Pix4D webinar, which is basically going to go through on how you get the most out of your survey data using the Pix4D suite. I know the guys are going to be going through Matic and Pix4D Survey as well. First of all, I'd just like to thank everybody for joining us today. This really couldn't be done without the support of software people like Pix4D, who's one of our partners, and as ourselves as a reseller in the UK and trainer. I'm James Pick. I'm the business development manager and a experienced surveyor and help and support our customers with using softwares like Pix4D. And I'm really pleased that Nate and Pierangelo can join us today and go through some of their features and why Pix4D is the leading brand in photogrammetric processing. So I'm going to hand over to the guys now, and yeah, they can tell you exactly what they're going to go through. Over to you guys.
Thank you, James. As James said, we're going to go through Pix4D Matic first, which I will present. I'm the software team manager for the Pix4D Matic team and product, and Nate Moore is going to present you Pix4D Survey right afterwards. So it's the whole workflow from images to your CAD and GIS data. I'm going to start with Pix4D Matic, which is here. The next slide, please. Here. Pix4D Matic is really for corridor and large-scale mapping. You might ask why. We have noticed that people are flying longer and longer on larger areas. Drones can fly 90 minutes, can fly in parallel. I will show you an example where in less than 2 hours, more than 10,000 images were gathered for covering a 6 square kilometer area. So somehow we need to treat all this data, and you need to be able to have a scalable solution for getting your dense point cloud, your orthomosaic. And so far, none of the existing photogrammetry software was built with this scalability in mind. And at Pix4D, we really wanted to address this trend and be at the forefront as we are in photogrammetry. And that's why we came up with Pix4D Matic. On the next slide, I will show you the workflow, which I briefly mentioned before. So first of all, I want to answer the question, what is a large data set? Here we look at 5,000 images or more. Those are at usually 20 megapixel or 42 megapixel resolution. You take these images with your drone or multiple drones. You can put these images with also ground control points or checkpoints into Pix4D Matic. This will give you your dense data and a scalable way of visualizing the data, but also processing it. And then for those of you who already are familiar with photogrammetry, you know that already now with smaller data sets, sometimes it creates large amounts of data. And that's where Pix4D Survey will really help you to extract only the data you need so that you can go smooth into CAD and GIS without any issue. So you will have your terrain workflow in Pix4D Survey and much more. And that's what Nate is going to present you right after. So basically you have 4 easy steps. You acquire your data, you put it into Pix4D Matic, you transfer it easily to Pix4D Survey, and then you are in CAD and GIS. On the next slide, I will show you what's new for those of you who already heard or tried Pix4D Matic before. What's new in the latest stable version 1.11 and preview version 1.12.1. Here, I'd like to briefly mention also that we release now every 3 weeks a new version. Once per quarter, there is a stable version, and in between a few preview versions. So there is new stuff coming all the time. Here, the latest ones are, first of all, an improved marking. Marking, what does it mean? It means when you need to add ground control points to your project or checkpoints, well, that's how you will mark them on the images to really be able to ground your photogrammetry into ground truth measurement, but also in order to check the accuracy. Same for manual type points, which helps you work on your project. The second one is the status center. This is really there for addressing the fact that you need to have some kind of insight into what happens when Pix4D Matic is running. You want to see what photogrammetric processing is happening or what notification the software tells you, and that's really giving you this additional transparency and control over what you can do in Pix4D Matic. And I will show you this in the demo. The third one is the import of geolocation and orientations of images. This is particularly useful for PPK workflows where you want to have your geotags in the right coordinate system, and that's how you can do it. And then the last 3 points are for the latest preview, which first is the auto GCP, how we call it. That's something that it's kind of similar to the improved marking, but here it's not the manual one, it's an automatic one that can automatically detect some specific targets, where afterwards you can of course check the quality and adjust if needed, but it's a really conservative algorithm and will most of the time be really accurate on this. And then the second point is the deghosting. That's something for some of you might have experienced this before when you have moving objects like cars where you fly. So you have some kind of a ghosting effect, and that's something this algorithm allows you to remove this automatically. So it's something it will take longer to process, but there is no more moving objects in your orthomosaic. So this is really improving the quality there as well. And last but not least, we have a new algorithm for densification, which is about 40% faster in average. So that's a huge improvement, because the densification was one of the steps that took most of the time. Now in the next slide, I will show you that we are compatible with all latest drones. So it's Wingtra, SenseFly, DJI, Parrot, and more. This is not an exhaustive list. Here, I'd just like to point out that we need to have geolocation and orientation data either in a CSV or text file that you import, or directly in the images so that it's compatible. This is also due to the processing we have. And something else I'd like to mention here is that we have also a generic camera model support, which, as long as you have a certain set of parameters in your images, it will support it. For example, all DJI cameras are supported through this mean. And if you want to see more cameras supported, please reach out to us. We're happy to add more compatibility there for you. On the next slide, I will show you the essential outputs. So we briefly mentioned it before. There is the dense point cloud, the orthomosaic, and the digital surface model. And there is a really easy way to go from Pix4D Matic to Pix4D Survey, as described in the workflow before. And Nate is going to show you this in the demo of Pix4D Survey later on. And next, so here is the famous data set I mentioned before. Here, 4 drones were flew in parallel at the same time, so 4 EBs, and in less than 2 hours, more than 10,000 images were captured. And there, we tried to process this data set in different software in addition to Pix4D Matic, and Pix4D Matic was the only one that managed to finish it. So here it's really the scalability that I was mentioning. It's not just fast, so it took less than 2 days for this huge amount of data on a quite normal, decent computer, but it's also able to finish the whole processing in one go without having to split it in smaller projects. It's just all 10,000 images at one, and that's really a huge time saver there. And the next project is one that was in the UK. So it's a disused coal power plant. Here there was a limitation on the flight height. This person had about 80 ground control points. So that's where you see how important it is to actually have a good marking workflow. And it took just 14 hours on this machine that you see here for 4,000 images. Now, the next slide, I will show you what this looks like in the software directly. So here I will first show the final result that we will get to. So here, this is a subset of this 10,000 image data set I just mentioned before. So you see that it's really loading quickly and you can move around easily. Maybe there is a bit of lag due to the webinar, but it's really something where you can zoom in and out quickly. You can here go to the 2D view, and here you see the sharp edges of the buildings, and how easy it's also to zoom in and zoom out even on large areas. So this is also part of the scalability. It's also this whole interaction with the results you have. And here it's the digital surface model. And here we will see that in less than 8 minutes, I can walk you through the workflow inside of Pix4D Matic to get to such results. Now in the next video, we see how we start from scratch to create a project. So we can either select the images or the folders, or create a new project from the file menu. What I prefer is to drag and drop the images directly, and it will just detect them. You can put a name, you can then load the images, and that's the status center at the bottom there. We'll see it a bit more afterwards. You saw it loaded. Here we directly see the images even without having done anything more than just importing them. You see them in the 3D space. You can then import the ground control points, and you can select here the coordinate system. And what's really key here is you see the options for geoids there. That's something where you can have the British geoid selected, which gives you this additional accuracy for your RTK workflow. Here you see that once you imported it, all of the data aligns. So that's perfect. You can go into the calibrate and start the processing. And there, once you started the processing, you see here the status center. So there really you can go into all the detail you need to see what's happening in the processing. You can go and see now it's, for example, processing the feature extraction. And that's really this additional transparency into what is the stuff you're doing, and that's where also you will see all the messaging happening. On the next slide, we'll see what's happening after you did the first calibration step. So you see, first of all, the sparse point cloud there, and then you can go to the quality report tab, and there you see everything's green, everything's fine. It was well calibrated. The GSD is about 2 centimeters. And then we see how you can mark the ground control point. So I selected the ground control point, expanded the window there. You can add more, up to 6 columns there of images. You can zoom in, and here you see it's super easy. I didn't have to select anything more. You can just start clicking and marking. So that's these improvements I was mentioning for the marking workflow. Now you can also go into full image viewer if you don't need the 3D for some reason. For example, if it's already well aligned, and that's where you can have even more images at the same time. You can also have the full screen image view to get more context of your project. You can also go from one image to the next there. And there you see also the error metrics on position error and reprojection error. And that's where you can also, in this type points table, it's where you can change from a ground control point to a checkpoint, for example. And that's where you can exactly choose how it's distributed, how you want to have your checkpoints in your project. And once you're happy, and of course, once you marked all your ground control points and checkpoints, you can re-optimize your project in the processing options. And the next slide is going to show you how it looks like once it was re-optimized. Then the first thing you want to do, of course, is to check the quality of your project. The quality of your project can first be assessed in the type points table. So there, the metrics we just saw before here, they're all full, and you can order all the ground control points and checkpoints by the size of the error, and that's how you will be able to pick out if there is any issue with your project. So here there was none, everything was fine, errors were small, and here you have the quality report panel to get the summary of this view too, and you can of course export the quality report as well at the top right there. And then if you're happy, as here it was all right, you can select the densification, digital surface model, and automosaic step, and of course also the exports. And that's where it's really key here. Here it's important to pay attention because it's a good trick for those of you who want to use the automosaic as a background map. Maybe you need a more lightweight result and something that is more easily importable into third-party software. That's where you can have this image scale option in this export tab there. So you can compress it, and if you want to use it as a vectorization, basis for vectorization, you can also export the full resolution, and you can also select the tiles, the tile size, and so on. So that's really something I would encourage you to have a look at. And on the next slide, yes, that's the famous question: what's the difference between Pix4D Matic and Pix4D Mapper? As we saw during this whole presentation, Pix4D Matic is really built for scalability. It's there for these corridors and large data sets of more than 5,000 images. And in these cases, it's really faster and more reliable than Pix4D Mapper because Pix4D Mapper was just not built for this scalability. Another advantage of Matic is that you can apply the geoid elevation to RDK data, which is not the case for Mapper, where you can only have an ellipsoid offset. And I'm mentioning this because first of all, for RTK data, it's important, but for large areas, it's even more important that you have really your accuracy there in the computations. Now, Pix4D Mapper is, of course, still and will be the gold standard for small to medium-sized projects. It's the Swiss knife of photogrammetry. It can take any kind of input, video, multispectral, thermal, fisheye, and so on. And my final message here is to really encourage you to see this as a geospatial suite. It's like a tool set for geospatial where you will pick the software that really fits your needs. Pix4D Mapper, Pix4D Matic, or Pix4D Survey. Pix4D Survey works with both of them, and Mapper is more for small to medium projects or complex projects, and Pix4D Matic is really for the large scale and corridor projects. Now on the next slide, I would like to encourage you to visit this website, pix4d.com/matic, for more information. And here I'd like to mention that there is a free trial available, so you can download the software, try it out on your own data, get the feeling for it. And here again, I'd like to mention that you saw that in maybe 10 minutes or so, I was able to show you how it works. So it's really, the learning curve is also not so big. So it's really something that you can try out easily. That said, I would like to pass on the mic to Nate, who is going to present you Pix4D Survey and how easy you can go from Matic to Survey to finish your workflow. Thanks for your attention, and I'll go to the questions in the chat. Thank you.
Great, thanks, Pierangelo. So yeah, I think what Pierangelo just said at the end there was a really good point, that we're trying to make it be an easy learning curve all the way through these two new products. But to introduce myself, I'm Nate. I'm the product manager for Pix4D Survey, so I look after it to make sure it's the right kind of a product to help you guys get your work done efficiently. We know there's a lot of things you have to do to make all of the data that comes through from your various photogrammetry tools all the way through to creating the stuff that your clients care about, and that's really where we are here. So really trying to make this big chunk of time go a lot faster. Our ultimate goal is that you shouldn't be flying for longer than you're reducing your data. I mean, for less time than you are reducing your data. You should be able to get the right stuff out pretty quickly. So I won't go into much detail here. I'm sure you all have suffered from some part of this at some time. And we're really just going to try and make it a concise workflow, give you the right tools. We're not going to replace the Civil 3Ds and microstations of the world, but we can make it a lot easier to move from one tool to the next and reduce the pain that you feel there. So that's the goal. And an important piece of that is extracting stuff quickly, but also the right stuff. So we're not gonna, we'll bring you automation, but you give you control too. You don't want to be getting bad data out of your good stuff that you have now. One thing that's really important for us is compatibility, but also those images that you've captured, you should be able to use them and carry through all the detail that you have there. They're a seamless surface. There's no gaps in those images, right? Worst case, you might have something obstructed, maybe by a tree. You can't see part of a facade, but you know how it works. You probably have some other images that cover that facade. You should be able to go ahead and get what you need from those. So that's what we're kind of showing here, where you can go through your project, and yes, you can work really quickly here in the point cloud, but you've got the details in your images. You should be able to come in here and refine it a bit. So that's what I'm going to show you as we get into the demo later on. The other big thing that we've kind of been working on tackling first is around the terrain workflow. So we've got some simple tools to remove noise from your project, to filter your point cloud into just two major classes, terrain and non-terrain, where we're not getting into things like high, medium, and low vegetation, just those two major classes. Some simple vectorization tools that you can then use to define break lines. This smart grid option that you see here in the bottom, where you can really just pull out points where you have areas of elevation change. So the most important points in the project in that sense. You can make a grid that uses this, make a tin that uses the grid and those break lines, and export it all out to XML and DXF, so you can really move forward with what you need. So here I'm going to talk about what was in the last stable version of Pix4D Survey. It's been out for about a month now. The big things were what you see here. You can import your DXF. So it's not an overlay, it's a 2D or 3D import. Your 2D stuff gets applied to a single elevation. The smart grid, you can follow road marks. I'll show you that, but you can follow dashed or solid paint in your project. We brought an orthographic view so that all that stuff that you know should be straight is going to be nice and straight. Some editing, a lot of cleanup tools, and then you can also merge point clouds from different sources now. And that's another thing I didn't mention before. I've talked a lot about photogrammetry, but if you've got LiDAR, whether it's from your laser scanner, whether it is from the Department of Environment, I forget what the UK Department of Environment is called, you know, any kind of aerial LiDAR, whether it's from a drone or public or, like I said, from your laser scanner on a tripod, you can bring all that in, merge it together on export, and work with it independently inside Survey. So I really encourage you to give that a try. If you want another use case to take a look at, this one is in the UK and it is about Pix4D Survey. It's a landfill site. Go take a look and you can see some of the ways that Pix4D Survey was used, in this case together with a project that was actually processed in the Pix4D cloud. So it doesn't really matter to Survey where that data comes from. As long as it is a Pix4D thing, we can understand how the images relate to the photogrammetry outputs, like your point cloud in particular. So like Pierangelo mentioned, it's super simple and straightforward to bring your project from Pix4D Matic into Pix4D Survey. So here's that same project he was showing off, and you can see it's really a simple thing. File, open in Survey, off it goes. And it's actually just going to push it right over and do it at the same time. So you can see that here in the left corner now. That you just need to give the project a name and a location and hit start, and it's going to start to bring it over into Pix4D Survey. So super simple and straightforward. It's painless, and do give it a try. It'll just pop right up, and we can take a look there. So if I get to my next slide. There we are. So in terms of what to do in Pix4D Survey, you can see here, again, the same project. Did I pause that? No, I didn't. And you've got a lot of the same kind of things you're going to be familiar with from other tools here. You've got your point cloud here. You've got your images here. Left side, it's actually changed a bit since this version, is going to be where all of your data layers, your point clouds, and everything else that you create is going to show up on that left side. So it'll take you a minute to find your way around, but I think from there you'll find it to be pretty straightforward. It's a nice set of tools to get everything moving pretty quickly. Now let's see. There we go. So if you can't find it in the menus, of course, you've got a set of other tools. We've got your select tools here, and that includes the ability to select, as we can see in a second here, either points in the point cloud, or you can be a bit more specific. If you pick somewhere in the project, it's going to bring up the same location in the images, so it's really easy to double check and see what details you've got going on there. How are we doing for time? I'm going to try and go a bit quick so that we don't slow you guys down too much and we have plenty of time for Q&A. But as you can see here, here's that selecting inside the point cloud. You can use that to reassign between classes, and you can even trim down what you're selecting. Like if you really want to select just part of a line, you can pick it here and just select some vertices, remove those. It's pretty flexible and useful. There's a nice set of manual vectorization tools. We won't go through that in too much detail, but I think you get the idea from what you see there of being able to mark things. Now, one key thing is that you are able to process all this stuff out as well. And that's where the real time savings come, is within all the processing options on the right side here. So with that done, let's, man, it really sticks here. One thing I wanted to show you is the road mark following. So just as I mentioned here, it'll follow paint in your project, and it's actually a little bit flexible. So it doesn't particularly care so much about the thing that you're following. As long as it has good contrast, it's going to work pretty nicely here. And so in this particular part of the project, you can see I've marked a couple things there already. Some of those are the curb, and then that's just a start in a direction to be able to follow that dashed paint. And you can see it goes off. It puts down a nice set of points along the way, so it's easy to verify that it's really on track and doing the right thing. Another thing you might have noticed there is that it went a little ways and stopped, but if we zoom into the project itself, you can actually see that was where the dash lines stopped for quite a ways. They need to do a little bit of repainting there. And you can see here where things are pretty tightly spaced, it's able to go right across and follow through those dashed and solid bits of paint, and you see it in the images as you go. So it's pretty flexible, it's pretty quick. And just for a point of comparison, I had a 5-kilometer project from a customer with some merges and some different styles of paint. In the end, in about 6 minutes, I was able to get all of that paint vectorized because it turned out to be just 11 segments of paint. So 11 times 2 starts in 2 directions, and you just let it go. So you can really sit back and have a cup of coffee while you watch it do your work for you. Go in, check on it, and then you can also tag it as a terrain layer if you're so inclined, and you can actually start to let it define your elevations in your project. So quick and easy. There we go. In terms of being able to work with all that stuff, let me just really quickly show you a bit of stuff from the same part of the project here. And in this case, you can see I've picked some other paint. You can delete an individual vertex. You can extend it. So if you have tried Pix4D Survey before, we didn't have all these editing tools, and it's made the whole workflow a lot more viable. If you want to split things in two, it's not super sexy, but it's new and it's going to be pretty useful, I think. In this case here, you can see I'm changing what the layer types are and how they're assigned. And then after that, that's some of the manual stuff. I went through, looked for any noise, didn't find much in the project. From there, it's that first binary filter of whether or not to, or how to classify the ground and non-ground. You can see here I'm setting an above ground threshold of about 20 centimeters, so pretty close. It's definitely not nearly as detailed as you'll find in a full classification kind of a tool, but so often this kind of a result that you see here is all that we really care about. Is it ground? Is it not ground? And then you can move forward with a lot of your work, right? So by being able to visually see them in different colors or just turn them off, you can really start to work nicely in the rest of your project. So for us, that's one of those simplification kind of tools that really makes it easy. Now, once you've done that binary classification, you can see here, I've got this blue grid of points that are equally spaced. That's exactly what it sounds like. It's an equally spaced grid. But on the right side here, you can see we've also got this Smart Grid tool. And that's what we see here in the yellow. So the Smart Grid is what I mentioned earlier. It's going to put points where there's areas of elevation change. So if you look in the stockpile here, you can see where there's tops and bottoms of slopes there. It's going to be more points in those areas, and your flat areas, there's going to be a lot less. So like we saw 30 seconds ago. And then from there, once you have all that defined, you can make a tin of the whole thing. It'll use your terrain layers as break lines, plus whatever kind of grid of points you want to give it. So you can see in that case, it wouldn't be so bad to have a few more on that stockpile if you were going to be measuring volumes. We can't do volumes yet, but when we can, you'll start to see more of that. And you can see here, I even have the different parts of the curb defined as parts of the terrain layers, and it really comes into the tin perfectly. And then from here, you can export that surface out to land XML. The rest of the project you can send to DXF. So I'm a Civil 3D user, so if you're moving over to Civil 3D from here, you're going to be able to bring everything over there just as you like. And in fact, if you want to send out just your grid of points, it's going to be manageable, because in this case, you can see it's 20,000 points. And we all know if you give 20 million points to Civil 3D, it's going to have some issues. But if you send 20,000 points off, you'll be on your way in no time, and it'll be super manageable. So I think that'll really help you quite a lot. Now, this is an example of bringing in the DXF data for a project where you can even include, it's a DXF, all your 2D and 3D stuff, and it can go beyond what you actually can see in the project, right? So you're able to bring in additional context here, boundaries, and underground features, stuff that's planned and not constructed yet. You can really start to tie it all together. And by looking at it in the orthographic view like we are here, then you've got straight lines that are straight. All this stuff would be just as you expected. The best way to test this is go somewhere where you've got some overhead lines, put it in orthographic and take a look, and you'll see that they're straight, just as expected. So while we don't have an orthomosaic for you to work off of here, I think you'll find that by working with the right parts of your point cloud and using that orthographic view, everything's going to line up just as you would expect, with the additional benefit of really being in a 3D space the whole time. So that's my main pitch for you, other than to go ahead and try it out. You can download from there. You don't need a license or anything to be able to get in, download, and try it. You can do quite a lot in the demo mode, and then if you need a trial license, you can probably talk to your favorite Coptrz salesperson. They can set you up. And otherwise, if you have any questions, ask us, let us know. And my apologies, I haven't been watching the questions while I talked, but I'm going to take a look there. And I don't know if you guys have anything else you want to say with these last couple of minutes here.
Yeah, just looking through some of the questions there, Nate. There's been a few which we've answered, but probably not too much harm going through them again. So John asked, can you confirm that the P1 on the M300 is supported in Pix4D Matic?
So this is what I meant before when I said the generic camera model. We already support it through the generic camera model, and in our next release, we'll also have it officially supported. So we have made a calibration to have it in our camera database. What you need to know there is that sometimes there is some angular information that from DJI is not totally correct. So you might have had to make some small changes. For example, if you use it in Pix4D Mapper, in Pix4D Matic, it should also work, in 99% of the cases without any issue. Just don't be surprised if there is anything happening.
Excellent, thank you. And I think Nate's already touched this from the demonstration, but very easy to put in LiDAR data from other sources, airborne, drone, terrestrial.
Yep. Yeah, and like I see you mentioned it there. Today it does have to be in the same coordinate system, but we're gonna that's a kind of major limitation. So soon we'll let you transform any of your inputs into the project coordinate system, so you can get everything lined up, no matter who your supplier is or how they're delivering stuff. If I can, I saw there was a question from Simon about exporting. So we're always adding to the list of exporting export file types, but we're really aiming to be kind of universally CAD and GIS compatible. So you'll see you can send everything out to a DXF, which is going to work almost anywhere in your CAD ecosystem. LandXML for the surface, and then we've also got shape export. GeoJSON will be coming really, really soon. And for your point clouds and your grid of points, you can send some of those out to DXF. You can send them out to LAS or LAZ. So I think you've got a good set of stuff there, but we're open. If there's a really special file format that anybody needs, you should let us know when we can work on it.
Brilliant. I know you guys haven't spoke about it necessarily in this presentation, but Tony asked about sharing the data. Can that data be uploaded to the cloud from Pix4D Matic as you can from Mapper?
So the thing is that the cloud is not built yet for the scalability. So as you might know, there is this limit of about 3,000 images on the cloud. So if you have a really big project in Pix4D Matic, the size of the outputs is for now too big for the cloud. If you have a smaller project, then of course you can upload the results to the cloud through the cloud interface at the moment. We are going to work on this more scalable compatibility with the cloud, probably for end of this year, beginning of next year, so that we can also have the larger kind of data sets that are easily shareable through the cloud. So for now, it's limited to the smaller ones.
Of course, if anyone did want to utilize the cloud, it'll have to just go through Mapper currently. Simon's asked about, and I know you've already answered this, but it's also supporting automatic vectorization, like built-up DTMs with triangulation.
So we're working on it. Automatic means a little bit of a different thing to everybody you talk to, and one thing we don't want to do is super automatic and triple your QA time, right? So we want to do it so it's the right stuff. But like you saw from the road extraction, or sorry, the road paint extraction, that's kind of a first step. And I'm personally really excited about what we're going to have in the coming 6 months or so around automatic stuff in general. I think it's going to be really cool what we can do. And it's going to be a mix of leveraging the images themselves and some from the point cloud. So I think that connection we have with the images is going to start to make it really interesting what we can do with Pix4D Survey.
And a question from Simon, and Simon's very good enough to join us yesterday, one of our survey summits, very experienced surveyor. He's asked about Pix4D Mapper. Any tips on getting tarmac roads to reconstruct with less noise? Something I get asked about a lot from customers. I wonder if one of yourselves could maybe answer that in a bit more detail.
So the issue with tarmac roads is that it's really homogeneous. So it's hard to find matches that are really the same point. So what I would recommend you is in the processing options of Mapper, there is the advanced processing options, and then there you can also choose how many matches you want as a minimum to be taken into account in the processing. So and the default is 3. I would go to 4 or 5, which should clean out all the matches that are not as sure as the ones that have 4 or 5, which means that they are seen in 4 or 5 images. So that's certainly a tip I would give you to increase how good it looks like.
Okay, excellent. And Simon's asked again, probably for you, Nate, on this one. Can the compatibility with the export data from Survey, can that be put into Bentley MicroStation and CAD?
Yep. Yeah, I think so. I'm much more on the AutoCAD side of things, but yeah, Bentley's good on their flexibility as well with the DXF and LandXML. You'll be in good shape there.
So I imagine Pix4D Survey caters with quite generic export formats, which makes it easy then for putting into other third parties to complete that workflow, which people are used to already.
Yeah, but if people really need Bentley's specific, I can't remember what their file types are, let us know and we can work on it.
Actually, I think Simon's also mentioned about POD files, POD data as well.
I don't know what that is. That's a good question.
No worries. Moving on. If anybody's a bit, I suppose, a novice and want to learn more about Pix4D, where's the best place for them to start and learn more? Maybe practice some data.
So for the data, we have example data sets on our support site. I will find you the link and put it in the chat. Then you can try out Pix4D Mapper or Pix4D Matic, and you'll have a good first impression of photogrammetry. And then I would also recommend to use Pix4D Survey for the next step in the process. As we just saw, it's the next step after photogrammetry.
Excellent. And I imagine, like most companies in this arena, in sort of the drone and survey arena, there's a lot of exciting new features coming out in both Matic and Survey. With you guys obviously quite ingratiated into this industry at the moment, where do you see it in the next sort of 2 to 3 years?
That's a great question. Personally, I think we're going to see more LiDAR coming out there, but it's hard to say. The photogrammetry is getting really, really great at the same time. LiDAR cameras with big sensors that can really bring back good imagery. So for me, I'm biased because I originally came from photogrammetry for forestry, but I think the idea of drones that can actually manage lightweight LiDAR plus photogrammetry at the same time to get really good elevation in areas with thick vegetation would be super cool. That's stuff that you've only been able to do from an aircraft with a major power supply in the past. But I think we've got to wait and see. There's so much change happening between government restrictions on what you can fly where, and then expansions of things into like beyond line of sight. Beyond line of sight is the obvious, really exciting one, but I feel like that'll be solved in 2 years. What's that?
I think there is another one too. So we have seen all this beyond line of sight and all the flying cameras, but there is also the ground and terrestrial cameras that are getting more and more attention. For example, Pix4D just launched a VDoc RTK rover for your iPhone. And this, what does it mean? It means that basically in a few months, or right now actually, you can already start combining this aerial data with more close-up shots from the ground, from your phone. And then the whole challenge with photogrammetry is going to be how to combine this data, how to make sense out of all these different data sets into one. And so that's a whole new challenge that right now it was mostly focused on the aerial part, and now the surveyor, I mean, surveyors also need to have indoor surveying sometimes, or ground where you cannot fly, and that's, or a curb, maybe you just want to walk around it and have a photogrammetry model extract the curb in survey. So that's a whole new era, I think, also that is going to come.
I think we're living in this generation now where it's so data rich from different forms of sensors, with it being either terrestrial or air, and we're in this kind of quandary at the moment where it's great capturing all this data, but how do we process it? How do we merge it all? And how do we get it into the hands of the people who want to use it most? And that might be internally within a business for further interrogation, but also getting it into the client's hands so that they can get that true value from it as well. And that's always an issue, certainly with sort of photogrammetric data. You know, it is quite heavy, and how do we share that is always a a stumbling point, which I think as an industry, and as we move forward in these exciting times, how we manage that and how can we conquer that, it's probably one of them small stumbling blocks at the moment. And just going back to what you said, Nate, about LiDAR, like you, I come from very much a photogrammetric background and really like photogrammetric data sets. I think they're brilliant. There's always this buzz about LiDAR, and we get asked about it quite a lot, you know, LiDAR, and I sort of have to stress the point that it's not the be all or end all. Photogrammetry, I'd say in 80% of applications works perfectly. There's just them other areas where LiDAR does come into its own slightly, with, like, you know, the vegetation penetration to a certain degree, or power line surveys to measure line sag. Yes, LiDAR really comes into that. But again, about using them data sets from either a LiDAR sensor and a photogrammetric sensor, and getting that workflow right on site of how to capture that data simultaneously and how to process it as well, will be big in the next few years to come. I didn't know if any of you guys wanted to add anything to this before we start wrapping up, or if there's any final questions anybody wants to type in.
One thing, while we're here, I just wanted to mention, you know, Pierangelo was talking about merging those data sets, and that's actually, I showed this earlier, didn't mention it. That's the source of this. So this is, so on the ground terrestrial plus the with RTK plus a P4 RTK. So it's that combined kind of an idea of a project, and look at the level of detail you can get out of this, you know, of the pipe run here. So it is going to be really cool as long as this data starts to become compatible.
Sorry, Nate, are you showing something on?
Oh, you know, I forgot I stopped. Did I stop sharing? Actually, I thought I was. No.
That's right. We can see, see your screen.
No, I said my piece.
But that's it. Sorry, no, I wasn't paying attention. My fault. No problem at all. Yeah, I'm just going to quick look through the question. Gary asks, do you envisage the ability to generate a Revit model from photogrammetric models or LiDAR point cloud automatically in the near future? And if so, how far away is this?
Yes, but I guess I think you said 2 or 3 years earlier, and that feels like a good time range. I'm hopeful for sooner, but it's really complicated to get clean enough data for what a Revit user wants. You know, it's got to be perfect faces and all that good stuff. And
I suppose it's
a great goal.
I suppose it's that combination between having it on both sides of the spectrum of having a really good quality sensor, and also the software and the processing power to be able to cater for that as well, and really get them features out and detail out which we require for something like a Revit model.
Yep. Yeah, and with luck, it goes beyond the geometry. Hopefully we can start to see a little bit more in the materials side, so we can use all that information that's really available in an image in the photos that we're taking. So
that's great. Well, if there's no more questions, I think it's a good point to wrap up. Thanks everybody for attending. It's been a really good, enjoyable 45 minutes of going through Pix4D Matic and Pix4D Survey. I'd like to thank the guys from Pix4D for joining us and going through the features of their software. It's really great to have you on board, and really great partner to have, and I enjoy working with you guys. If anybody does have any or want any further information about the Pix4D packages you've seen, or want to just go through any of the processes in it, then please feel free to reach out to myself at Coptrz, who can help and support you along the way with this, as well as obviously purchasing the licenses from ourselves. Is there anything to add from you guys before we go?
Thank you for inviting us, and it was really a great pleasure. Thanks, James, and all the people who attended.
Brilliant.
Yeah. Thanks, everyone.
Cheers. Thanks, Nate. Thanks, Pierangelo. Nearly got your name wrong. I did. Cheers. Thanks, everyone.